In Chapter 2, we're going to be focusing on equations and inequalities. And to introduce that, we're looking at what's called a rectangular coordinate grid or a Cartesian coordinate system. And that involves two perpendicular axes. The x is here and the y is here. And in this example, they've just overlaid it with a map. And these points are points that this person stopped at. And they happen to be at intersections of the vertical or horizontal lines here. The coordinate system is broken up into four quadrants. The first is where x and y are positive. The second, and it goes counterclockwise. The second is going to be where you've got negative x values and positive y values. The third is where you have negative x values and negative y values. And the fourth is where you have positive x values and negative y values. So in this example, we're looking at a particular point. The point is 3, -1. So this is your x value and this is your y value. So to plot that, you would go positive 3 on the x-axis and then -1 on the y-axis. So that's going to put you right there. And here's some more points. So if you had 0, 3, you would go 0 on the x and -3 on the y. Here you would go positive 3 on the x and up 3 on the y, positive 3 on the y. And then here you have -2 and a positive 4, so you would go -2 on the x and up to 4 on the y. Here's an example where they had a linear equation and they plugged in several different points, and you can see all those points created this line. Here's another example. This one is increasing and this one is decreasing, or it's negative. It has a negative slope. I'm not going to go over much on the calculator graphing. You're welcome to explore that more, especially if you have future math classes that address this, but I'm not going to focus on it too much in this class. Here's an example of a graph with a negative slope. And here's an example with a positive slope. This one is focusing on intercepts. So when you have an equation, you can plug in x equals 0 or y equals 0, and that will give you your intercepts. So this one is your x equals 0, and that will tell you what your y-intercept is. And then when you set y equal to 0, that will tell you what your x-intercept is. In this example, it's showing you how we derive the distance formula. So if you want to find the distance between this point and this point, you can use the Pythagorean theorem. I don't know how much you remember that one, but that's the one that says, given a triangle, the straight legs are a and b, and the equation says that a squared plus b squared equals c squared. So what you can do is you can find out the distance from A and the distance of B, and you can solve for C. And here's an example where they've given you the actual points, and they want you to calculate that distance. And now this is the map grid that we saw at the very beginning. And they've gone ahead and marked where those points were on a coordinate system. So the stops that the student made are all right here. These are where those, almost like an address, like what that address would be in XY terms. Here's the midpoint formula. Sometimes you're going to want to find the midpoint between 2 points. So you would... these are showing that these sides are congruent, or they're identical, they're the same, they're equal distance. So if those are equal distance, then here's the midpoint, and to find that value, you can plug in your x's and y's into this formula here, and that will tell you what that coordinate is right there for the midpoint. Here's an example, a real life example. In this particular problem, the student was wanting to go on a vacation, and they decided that was going to take them $2,500. So this red line is their goal. They started out with $500 in the bank, or this looks like a little less, but let's $450, something like that. So that's why their line starts at $450. That's what they started the account with. And based on their rate and the number of hours they worked, this shows how much they can earn towards that goal. So this particular word problem had a lot of questions about how many hours would they have to work, what rate would they have to work at, that kind of thing. So as you can see here, it's going to take the student 140 hours of work to make their vacation goal. This one is just showing you examples of various slopes for the lines. So here we've got a fractional slope, less than 1, and it's going pretty flat. If you had a 1-to-1, it would kind of go straight, be a nice 45-degree angle. Here's a 2x, so it's going to be pretty steep. And then a negative 3x, so it's also going to be steep, but it's going to be steep going down and being a negative line. And in this example, it's showing you some of the vertical and horizontal lines that you might come across. These ones always goof me up, so they're probably going to goof you up as well. So it helps to plot a couple points so that you get which way you're supposed to be going. So for y equals -2, you can do x equals 0, y equals -2, and let's say 3, y equals -2, and that's going to remind you that it's going to go this way. Otherwise, it's pretty easy to accidentally do it like this. You don't want that one. You want to make sure you're counting your y. And same thing here with x. So for x equals -3, we're going to go along the x value to -3 and make a dot, and then pick any other one. So here's 1 and go to -3 and make a dot. And then you can just connect those two. This one is showing you parallel lines. So parallel lines, the unique thing that they share is the same slope. So they're all going to start with 2x, or whatever that slope is. In this case, it's 2x. And this number right here is showing you what the intercept is. So we've got a -3 intercept. So you can see here, we've got this one right here. And then we have a +1 intercept, so right here, and a +5 intercept, so that's right here. In this example, we're talking about perpendicular lines. So this is when you have a 90-degree angle between the two, and this is called a negative reciprocal. So anytime you want a perpendicular line, sometimes it's denoted as this, or sometimes it's denoted like this. Anytime you have a perpendicular slope, it's going to be the negative inverse of whatever the original one. So this one is 3x, so the perpendicular slope would be -1/3. Or if you started with this equation, it would be a negative inverse, so that would turn this to a +3. So those would be, this doesn't necessarily have to be the same, but your slope would be the negative inverse or the negative reciprocal. Here's another example. So you can see the one is a -4/3 and a +4/3. I'm stopping because I think that's wrong. That should be, sometimes there's errors in these. So one of these should be the opposite, so 3/4. And in this one, they're parallel. So you can see that the slope is the same on those. And I'm going to go ahead and stop here, and then we'll cover the next section in another video.